Alright, hi guys. So today we are going to learn chapter 5, which is network in graph theory. So what do you think about the network here? So like a social network, or maybe like in telecommunication network here. So this chapter we are going to learn simple graph, multiple edges and loop, directed graph and weight graph, transportation network, and subgraph and trees. So we're going through this one by one. So first thing, we have to learn the network first. So what do you mean by network? Network is a part of a graph with the vertices and edges having their own characteristics. Okay, so graph is denoted by a set of ordered pairs. G equals to VE. V is vertices. This is a set of dots of vertices. This is off here. Of vertices. E is the set of edges or lines linking each pair of vertices. And then the degree D is the number of edges that connect two vertices, which is dv equals to 2e. This you have to remember, 2e, whereby v is elements of v. Okay, so no issue. So next we have to see simple graph. So what do you mean by simple graph? Definitions. Simple graph has no loops and no multiple edges. Later we will see what is loops and not what is multiple edges here. So the sum of degrees is the graph is twice the number of edges, so it is 2e. Okay, degree equals to 2e. Okay, so we see example 1. Based on the simple graph given, determine v and nv, which is vertex and number of vertex. So let's see. A, v. What is v? You have to write in the set. You have to write in the set, so which is 1 2 3 4 5 6. So you have to write 1 2 3 4 5 6, and then number of v is 6. Okay, so B, we have E. What is E here? So E stands for the edges, so you have to write in terms of coordinates. So here 1 2, 1 go to 2, so you have to write like this, 1 2. Some more, we still have 1 to 5, 1 5. Next you have 2 2 3 and 2 4. Okay, so we write 2 3 2 4. Some more, we have 3 4 3 4. Some more, we still have 4 5 4 5. Okay, we have 5 6. So total here will be 7. Number of E is 7. Is it 7? 1 2 3 4 5 6 7. Correct. This is 7 edges here. Sum of the degrees. Sum of degrees. How much? Is 2e, which is 2 times 7, which is 14. Okay, so we see the example here. State the number of vertices, number of edges, and the sum of degrees. Sum of degrees. Okay, here also the same, number of vertex, number of edges, and also sum of degree. Okay, so number of vertex, we have 1 2 3 4 5 6 7, so we have 7. Number of edges, so we see 1 2 3 4 5 6 7, also 7. Sum of degrees, as I said just now, is 2e, which is 2 times 7 equals to 14 here. Okay, Next questions, we look at B. So number of vertex also 7. A, B, C, D 4, E, F, G 3. So it's 7 here. Number of edges here is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it should be 9 here. Sum of degree 2e, which is 2 times 9. You get 18. Okay? This is the example 2. So after we see the simple graph, so let's see multiple edges and loops. So what do you mean by multiple edges? Involve 2 vertices lah. Is no issue. So the vertices that are connected by more than one edge, like this, this PT, they appears 2 times here. So this is, we call it as multiple edges. So sum of degrees is twice the number of edges. So sum of degree here will be 2e, which is 4 lah, because 2 times number of edges here is 2, so it will be 4. Okay, and then loops is 4 if one vertex, and then the edge is in the form of an arc, like I mentioned just now, is a circle, a small circle, or I can say is an arc lah, and starts and ends as vertex that starts and ends at the same vertex. So in if you want to write the edges, it will be like this, as S, or maybe they have maybe this is 1, or okay, I can write it as 1, 1. Okay, each loop adds 2 to the degree. Let us see later. So let's see these questions. Sorry. The diagram on the right shows a graph with a loop and multiple edges. State V and MV. Okay, A. V here is how much? V here is PQRSTU. No issue here. So just write it out. PQRSTU. If this is a vertex, number of vertex is 6. Okay, no issues here. B. E, you have to be careful with the E because it appears 2 times like PU, so you have to write 2 times. PU 2 times. Some more we have PQ. Next we have QR. QU. No more already. So we have RS. RS and RT. So we have SS. Because why SS? Because S is a loop here, so you have to write it SS. Next we have ST. We have TU. UP we didn't write lah because it is already written as PU here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 edges here. So number of E equals to 10. C. Sum of degree equals to 2E equals to 2 times 10. You get 20. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct lah. This is 10 edges here. So your sum of degree here is 20. Okay, next. So they asked you to draw a simple graph based on the given information. So we have 5 vertex, 1, 2, 3, 4, 5, and then this is the E. So you have to draw a simple graph. So we can draw like this. Because in this chapter you have to imagine what is the shape of the simple graph. So that when you are draw, it might happen when the line are crossing each other, but never mind, as long as the shape is reasonable and it can be more beautiful, it will be enough lah. So let's see, we can write the 1, 2, 3, 4, 5. If you want to jump here and there, but as long as it's come out with all the closed surface lah, you cannot open surface. if how to say, um, not only start. So if you want to jump the orientation here, so it depends on whether the shape is more reasonable or not. Okay, so let's see. 1 2, so I connect 1 to 2, 1 4, 1 to 4, 1 5, 1 to 5. Okay, 2 to 3, 2 3, and then 2 to 4, and then next is 3 4. This will be the shape lah. 1 2, and then this is one shape, another shape here, and then so the shape will be some sort like this lah. Okay, sorry that I couldn't use my ruler to draw it very nicely. So this will be the shape here. Okay, so next we see PQRSTU. So I can draw like this: P Q R S T U. Okay, but you can see PT, you cannot draw like this straight away. I cross R, it cannot be like this, so I cannot write the orientation like this, so we have to change here. I can draw like this: P Q R S T U. So we can have PU. So PU, I can draw from here. This is PU. PT, this is PT. And then QT. QT is like this. QS. And then RS. And then we have RU. Okay, so the shape, it can be like this, or so it will be more complicated here. So I also want to change the orientation here. So let's see. So the orientation I can change like this, and STU. Okay, so we make it more nicely and very beautiful here. So we can draw PU, and then PT, and then QT. We have QS, because okay, QS, we have RS, and then RU. This will be more nicer. And sorry again, I couldn't use the ruler to draw it nicely. Please use ruler to draw the lines. Okay, next, draw a graph with multiple edges and loop based on the given information. A, we have four vertex here. P Q R S. Okay, so P okay, confirm this is a loop. PQ, so PQ. PS here, from P to S. QS, this is my QS. QS got 2. Okay, and then we have QR. We have QR, and then we have SR. So I think this is very weird shape, so I will try to change a orientation here. So I will change like this. I will change my orientation like this. So this is my P Q R S. So I have PP, this is my loop. RR, this is my loop again. So we have PQ, oh sorry, we have PQ, we have PS, we have QS, I have twice here, QS, we have QR, we can RS or SR, and then the loop here. Okay, this is the shape lah. Next, we see we have 7 here, so we can like this: 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 6 1 6 got 2, so 1 6 have 2 2 7 2 7 here got 2, 5 7 got 2, 5 7, 3 4 2, we have 1 7. Okay, I join 1 7, 6 7, 3 7, and 4 7. This is the shape. Okay, later I draw it nicely first. Okay, this will be my shape lah for the graph here. Okay, so the main point here is you have to figure out what is the shape, and then when you find that, oh, this very weird, so maybe you can change a bit the orientation, like 1 2 3 4 5 6 7, or maybe you can change the orientation, see whether the graph looks very easy, very nicely, or you can make it, you don't want to make the graph as complicated as possible. No, we don't want the complicated graph, we want just simple, just you can see very nice, very beautiful graph. You have to imagine the picture of the graph here. Okay, so this chapter will be more imagination, so you have to think about it. Okay, no worries. Next, determine whether the graph with the following degree of vertices that can be drawn. Okay, so in this chapter, in this, so you have to calculate the degree of vertices first. A, you add up all 3 plus 2 plus 2 plus 1 plus 3 equals to 11. So as you can see, our sum of degree here is 2e. It must be an even number. So I can say therefore this graph cannot be drawn. Why cannot be drawn? Because the sum of degree is odd. Be careful when you find out the sum of degree here is odd number. You can tell the examiner that examiner, this is odd number, so I cannot draw. If you want to draw the simple graph or multiple graph or loops, you have to make sure the sum of degree is even number. Only even number, then you can draw the graph. Okay, so let's see. Next question. 2 1 1 3 3 2. So you add up first. 2 plus 1 plus 1 plus 3 plus 3 plus 2. So you get 3 4 7. 7 plus 5 is 12. Therefore the graph can be drawn. Why can be drawn? Because the sum of degree is even number. Okay, so you can try to do the exercises, and then next video will be talking about the subgraph, and we'll be talking about the directed graph and undirected graph, and weight graph and unweight graph. So let's see the next section here. So we see what do you mean by directed graph and what is undirected graph? So directed graph is the graph which a direction is assigned. You see direction is assigned to the edge connecting two vertices like diagram 1. So they have the arrows here, arrows and arrows. So this is directed graph. So the diagram 2 also the same. You have the E1, this is the direction, 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 direction. So this is, we call it as directed graph. What do you mean by undirected graph? Like this. Okay, so we have A, B, C. They didn't give any direction here. So this is undirected graph. Okay, so undirected graph is a simple graph or a graph with loop and multiple edges drawn without any direction being designed. We just say just now they don't have any direction, so this is undirected graph here. So this is the difference between the directed graph and undirected graph lah. So set V and E, okay, so not an issue. So the degree for both vertices you'll be no issues lah, it's also the same. But in directed graph like this, AB, so AB is from B, they go to A, the arrows is go up, so you cannot write AB, you must write BA, because it's from B go to A, from B go to A. So this is the how do you write the edges for the directed graph. Okay, so here you have to differentiate between degree in and degree out. So in is from other vertex goes in. This is from the particular draw in and write it nicely. So this is the particular vertex go out. This is like degree in A, so from other vertex goes into A. Degree out A here means from A they go out, from A go out to another vertex. So let's see this. You see A from degree out, so degree in A is 2, so where is the 2? So from other vertex go into A, from C go into A1, from B go into A another one, so here is 2. Degree out A is, you see the arrow, is it got any direction from A go out or not? No, so for sure this is 0 lah. Going into vertex A or coming out from vertex A, you have to differentiate the degree in, degree out here. Next, degree in B is 0, so from go into B, so is it have any vertex going to B or not? No, so it will be 0. Degree out B is coming, means the number of edges coming out, so is it got coming out? Yes. From B go out 1, so from B they go out 2, so here is 2 lah. The number of edges going into C, yes, we have 1, another 1, so here is 2. Coming out from the vertex C, which one? Out from vertex C, so got 1 lah, so here is 1. Degree in, so here will be going into D. Going into D 0, we don't have. So coming out from vertex D, we have 1. From D they go out, so will be 1. So degree here still the same, is 8. No matter the going into vertex or coming out to the vertex, the sum of degree still the same. Okay, this is for simple graph. Graph of loops, be careful of the loops and multiple edges here. Okay, undirected graph, I think not very much issue because we already do more exercise regarding this. So I will more focus on directed graph. So PQ, from P goes to Q, the arrow, so will be PQ lah. Cannot write QP because the arrow does not show Q to P, it's P to Q, so you have to write PQ. Okay, so I already mentioned the coming in P and going out from the vertex P. Beware from the loop here, because T here is a loop, so I mentioned already, if the loop, the degree must be 2. So 2, where is the 2 come from? So when you draw a loop, one will be like this. This is anti-clockwise 1 degree, another one is clockwise, another one, so it will be 2. So if this is a point, this is the point T, so from T I turn around back, I go into T, so degree in T, also degree in T here is 1. Another one is from T I go out, turn around, I go back, so here degree out, so coming out from T also 1. So this is the degree of loop lah. So degree in T we see, because coming in, is it any coming in T from the P and S? No, only the loop, so is 1. Another one is going out lah, so it will be another one also. So another 2 will be TP, T go out to P and T go out to S, so another 2 here, so will be 3. Okay, so be careful when you're facing the question regarding the loops and multiple edges. Okay, so this is the difference, so you have to, this is the weight graph and unweight graph, so you have to read yourself. Okay, so let's see the example here. So draw a directed graph based on the given information, so given V and E. So how do we draw the directed graph here? So we see A given here got 6 vertex, right? So we can draw like this, so P, Q, R, S, T, U. Maybe I can draw like this, P, Q, R, S, T, U. So we have PQ, so P to Q, okay, arrow. P to R, we have another arrow here. R to Q, okay, R to Q. Some more, S to R, S to R, S to Q, S to Q, S to T, S to T. This will be my directed graph here. Okay, so sorry for the lines, so you have to use your ruler to draw. So let's see the B. There is a loop at vertex Q and RS is a multiple edge such that this, okay, they've given the degree in and degree out. Okay, so let's see. We have 4 edges. P, Q, R, S. So we have Q is the loop. Q is a loop. Okay, I draw a loop first. I draw a loop, and then RS is the multiple edge, so RS is the multiple edge. So degree in P, so it's 1 out of P is 1, so we see the degree in P, so for sure this is 2, so 1 and 2. Okay, some more. Q, for Q is 5. 1, 2, 3, 4 and 5. Okay, loop is 2, then another 3 lines here is 5 lah. And then R is 0, out is 3, so R is 0, that means that others point go to R will be 0. So here is 3, all are out. So from R I go out. From R I go out. From R I go out. Although it is 3, so but the from R they go out, the degree from go out from R is 3. So this will be, the arrow will be like this lah. So next, degree out of S, from S I go out, is 1. So I don't know whether it is. So let's see. In P, so from here, degree out of S is also equals to degree in of P. So you can see this one. So this is the one. From S that goes to P. It means that S go out but P is come in. So it should be from S go to P. Okay, we already settled the P already. So confirm this is out. Okay. Next, if Q is in is 3. So we have 1, Q is 1, a loop is 1, and then go into Q, so another 2, so it is 3. Okay, no issue already. Out from degree out of Q, one is loop and another one will be here. So this is the directed graph for B. Okay, so okay, let's say the questions will be the same questions will be some sort like this. So you have to really one by one calculate whether the points goes the degree in P and degree out of P. So you have to know how to draw the directed graph here. Okay, this is just an example from the textbook. So next question. Diagram on the right shows the one-way path that Izaro can choose for his running practice. Vertex 1 is the starting position and vertex 5 is the ending position before he goes home. Determine the shortest distance from V1 to V5. You have to calculate the shortest distance. So which one do you think this is the shortest distance from V1 to V5? So I can draw V1 to V3 to V5. Okay. Some more. It also can from V1 go to V2 go to V5. Oh, sorry. This is V4. Sorry. V4 go to V5. So another way he can go is V1 go to V2 go to V3 and go around V4 and go to V5. Okay, so also V1 go to V2 straight away go to V4 go to V5, another route. So we see which one is the shortest distance. So I think this is the shortest distance lah. So we see V1 to V1, V3, V4, V5. So we have V1 to V2, we have 500 meter plus 600 plus 500. 600 plus 500 meter equals to 1.1 kilometer here. Okay, this is for A. And then for B is the longest distance. This is the shortest. This is the longest lah. V1 to V2 we have 600 plus V2 to V3 900 plus V3 to V4 500 plus V4 to V5 also 500 equals to, here is 1019 2.5 km. So this will be the longest. And then C, this is for B. So for C, the vertices that must pass through if the distance of the one-way line is between 1.4 and 2.1. So we also have to calculate both roots in order to make it between 1.4 and 2.1. So we see the first here, v1 to v3, 500. v3 to v4, 500 also. Some more we have 500 equals to 1.5 kilometer. It should be okay lah. So another one, we also can try it out. v1 to v2, 600 plus v2 to v4, 800 plus 500 equals to 1.9 kilometer. So you can choose both two here. You can choose, so you can choose either one here lah. v1 go to v3 because this is between 1.4 and 2.1 lah. Okay, so you can choose either this route or this route. Then it should be okay here. So you can do the self-practice exercise before we proceed to the subgraph and trees. Okay, so let's see. We have subgraph and tree. So what do you mean by subgraph and what do you mean by tree? So subgraph is a part of a graph or the whole graph redrawn without changing the original position of the vertices and edges. Okay, so we see the example straight away. We see, so the given graph is this. So you see diagram 1. Diagram 1 is diagram 1 PSE5. So you have to determine whether this is subgraph or not. So we can say confirm diagram 1 is a subgraph. Why this is a subgraph? Because E5 is connected between P and S. Okay, so you see P and P connect with S with the line E5. Okay, let's say P connected with R with the line E6. In the graph G, would it has P connect to R is E6? Confirm is no. So this will be not a subgraph. So let's see diagram 2 here. Diagram 2, we have P in the loop E2, and then P connect to Q is E1, P connected to S is E5. So confirm this is not a subgraph. Why? Because E2 is not the loop P. It should be loop Q. You can also justify that, or you can say, you can determine, or you can explain why this is not a subgraph. I think should be okay to give a mark to you. Okay, so let's see the diagram 3. So we can Q here, E2 is correct already, but P to S is E3, should be E5 here, so also not a subgraph. Why? Because E3 does not connect P and S. Or you can say that E3, so P connected with S should be E5, not E3. Also can. Let's see the question, the diagram 4. So we have E1, confirmed wrong already because the loop Q here should be E2, not E3. Okay, so it's also not a subgraph. Why? E3 is not in loop Q. Okay, so I hope you understand what is subgraph. So next, what is tree? Tree is a subgraph. Remember, if you want to draw a tree, make sure this is a subgraph. You see, this is not a subgraph, confirm this is not a tree lah. So, but the tree, they have the following properties. One, this is a simple graph, no loops, no multiple edges. And then all the vertices are connected. Each pair of vertices is connected by only one edge. Only one edge, okay? So it means that, like, I give you another graph here. So you have graph like this. So I want to find the tree here. Oops. I want to find the tree here. Okay. Oh, sorry. So later I will do so I will draw like this lah. So I want to find the tree from this graph. So how do you find the tree? So my tree will be like this. It should be like this because you see all the vertices are connected with only one edge. Let's see, is it this a subgraph? Yes, this is a subgraph. But is it a tree? Yes, this is a tree because you see all the lines, they are connected with only one edge. So you can see this point to go to this point, only one. This point go to this point, only one edge. This to this point, only one edge. This to this point, only one edge. It is also a tree. This is we call the tree here. Okay. So you can see the diagram 1. Diagram 1 is the tree because all the vertices, they are connected. All the vertices, they are connected here. And then each pair of vertices is connected by an edge only. No loop, multiple edge. 5 vertices, 4 edges. Yes, correct lah. 5 vertices, there are 4 edge here. So you can see number 3. Number of edges equals to number of vertices minus 1. So we have 5 vertices here. 1, 2, 3, 4, 5. And then your edges, number of edges should be your number of edges. Number of edge should be 4. Confirm this is 4 lah. 1, 2, 3, 4. This is 3. Okay. I hope this is very understand. If cannot understand, you can telegram me. Okay. So let's see the example here. So 2 trees based on the graph given below. So we know this is 5 vertices. So your number of edges should be 4. This your number of vertices here is 1, 2, 3, 4, 5, 6. We have 6 here. So your number of edges should be 5. So we draw the number of edges for A first. Okay, the tree. So I will draw like this. 1, 2, 3, 4. So this is one. This is the one tree. Another tree come from where? Another tree will come from. Okay, so same here. I can draw like this. 1, 2, 3, 4. Both are the trees here. Okay. Another B. So I have to draw the 5H. So we can draw. I draw the vertices here. So my edges. This is my edge. My edge. 1, 2, 3, 4, 5. Okay. This is one tree. Another tree is where? Where is another tree here? Another tree will be. I'll give you another tree will be like this. 1. Oh, sorry. I think I draw the vertices nicely first. 1, 1, 2, 3, 1, 2. So my tree will be like this. 1, 2, 1, 2. So you can see 1, 2, 3, 4, 5. This is also the tree. This is the example here. Okay. So next, example 13. So the following diagram shows an undirected weight graph. So draw a tree with a minimum total weight. So you have to draw the tree with a minimum total weight. So you have to, after you draw the graph, you have to draw a tree. Sorry, you have to draw the tree. You have to calculate the total weight here. So let's see how many vertices here. 1, 2, 3, 4, 5. So this is five vertices here. So you have to draw the tree with the number of edges of 4. Okay, so we have to draw the tree here. So where is the tree? So we can draw like this. So we draw the, okay, so this is confirmed. We have 2 already. Another 2 come from where? You can draw like this. You can draw like this. Okay, 1, 1. But is it all the is it a tree? Yes, this is a tree. 1, 2, 3, 4. But is it a minimum total weight? So we see this is 25, this is 19, 14, and 11. So you calculate here. You calculate whether this is a total minimum weight or not. So we see, we add up here. So you get 69 here. So, but I also can draw the tree like this, because this is, you have many trees here, but you have to choose the minimum one. So we will draw same base. Okay, we have the lines here. It also connected each of the vertices with one line. So we have 10, 12, 19, and 14. So you calculate the total weight here. How many? It should be 55. So this tree cannot be used anymore. So I will prefer this, because this is, I think this is the very minimum already. So your answers is this. You have to draw this. This is your answers. Okay, you can also try to draw as many trees as possible, but you also have to calculate whether the weight is it the minimum, the smallest one. Okay, so you have to do the self practice, do at home. So if you have any questions, you can just ask me. Okay, so we will proceed to the next subtopic here. Okay, so we will moving on to the next subtopic, which is the represent information in the form of networks. So in our topic, we will learn 2 types of network. One is transportation network and one is social network. So you can see this map. Yes, I'm very familiar with it, because this is when I go to KL. This I will use this to guide me to the destination. Like I'm from Upsi, from Tanjung Malim. Actually, this is the Tanjung Malim. Sorry, it's not clear. This is a Tanjung Malim station. So I would like to go to the KL Central. This is the KL Central. So this will be the one network from Tanjung Malim here. Take commuter commuter to the KL Central here. So this is also a kind of transportation network. And also from KL Central, you can take the commuter, go to the Batu Cave. You can take your Rapid KL. This is the LRT. And then also you can use KL Central and then go to the airport. This is also a kind of transportation network. So it can be shown as way graph and unweighted graph. So the way can be distance, traveling time, or cost of the journey. So basically you go to the station, train station, you can see the price of the ticket, like from Tanjung Malim I go to KL Central, how it costs, and then the duration of time and also the distance here. It will be list out here, but mostly they will list out the time and then the ticket money lah. Okay, so next, the example of transportation networks are, we already familiar with it, GPS. For those who are playing Pokemon Go, yes, I'm the Pokemon Go player, so GPS, if there is no GPS, I couldn't catch any Pokemons here. So this GPS, also we call it a kind of the transportation network here. Okay, so next, very familiar, this is I take from the G map, or we call it Google Map here. So Mr. Woon and his family plan to visit historical places in Malacca. So the map shows 3 alternative routes with the distance and estimated time needed to travel from Tangkak to Air Formosa. So, and then assume P is this is P, where is the P? P is the 46.3, so this is P, and then we have Q here. Okay, this is Q, sorry, and then this is the R. This is the R route. So why does P take the longest time compared to the others route, even though P is the shortest route? Why? So actually, if you see, if this kind of question is coming out, so how do you write it out? So I write the answers here. So I can say route P takes longest time. Why it is take longest time? So you have to think about, when I travel from Tangkak to Air Formosa, so I will pass by many cities. So there is more car, more traffic lights. So the duration of time takes will be longer. And then others might be the kampong route, and then if kampong road, so it will be take the longer distance. But if kampong road, there's nobody drive, so you can you can drive faster. So I can say, because this route passes through crowded town, and more road users lah. So I say, so many people drive in this road, so you take longer time. It might be have the traffic jam here. So you can justify a bit, might have traffic jams. Some more, also you can give any clarification. Many traffic lights also can, as long as this is more reasonable reasons. It should be okay, like a KPKK questions. Okay, so we see we have the table shows the choices of public transportation, estimated traveling time, and estimated cost for a journey from Johor Bahru to Kota Bahru. So you have the table and then the price here. So based on the table, determine type of transportation that should be chosen for the situation given below, and you have to justify your answer. Okay, so a journey involving an adult without time constraint. Okay, so what does it mean? So okay, so without time constraint, so how, in the opinion, what is the type of transportation suitable, I mean this, what, in order to make it very suitable, so what does it mean here? Without time constraints, so it must be the longest time. Okay, so we see longer time will be 17 hours, so we will choose train. Okay, so we will choose train because without time constraints, so we don't no need to be rushed here. And then we have, okay, so since we already choose train, and then next we will choose whether with bed or without bed. So 17 hours, you think about it, is you have to sit on the train 17 hours, more than half days. If without bed, you will be suffering. So it means that, so I will choose bed lah. Okay, so you can see, although the adults, so what's here, we have adults and adults, so we have 49 to 55, but although they have some the price, the difference in price here, okay, but the difference in price, you can have a good rest. I think this is worth lah. So I would choose train with bed. With bed is the choice, is the best choice. Why this is a best choice? So passenger can have a good rest throughout the whole journey, and cheaper than cab. Okay, so this is the answers for A. So let's see the answers B. The journey involving an adult with time constraint. So we have limited time already. So it means that, so I need to go to the destination with the shortest time. So we have 9 hours here. So compare bus and cab. Which one is more cheaper? So confirm is bus. Okay. So I can say, I can justify here bus. Okay, because the duration of journey is shorter than the train, and more cheaper than taking a cab here. Okay, and then C, the last one. So a journey involving 2 adults and 2 children. So although they say doesn't say that, oh, time constraint or not, but I can say you are having your family here, 2 adults, 2 children. So I will choose the cab here. Cab, because most economical choice. Okay, so you can calculate yourself whether 2 adults and 2 children for taking bus, taking train with bed, taking train without bed, and cab, what is the difference here? So you can see for sure you taking a cab is much more cheaper than bus and train here. Okay, so this is the social network. So you see we have the Facebook, Instagram, WeChat. This is the social network here. Okay, so this is the example for the network. So we have 2 in this subtopic. One is transportation network, one is social network. Okay, so we see the examples here. So this is the table below, shows the data of 6 people and the game they like. So represent the information in the form of network. So they give you like this. So okay, so how do we gonna interpret the data into the terms of graph? So I will start from so we may start from the badminton and chess here. So we can draw. Here is my badminton. I will connect it to chess. Here is Edmund. And then chess I can connect with a football. So it will be Rajan. Okay? And then football is also connected with sepak takraw again. So the person here is Azwan. Okay? So chess, it also have another point with the netball is Aina. Badminton and netball also can connected together. Here is Maria. Okay, netball and volleyball. So here is volleyball is Jenny. So this is the example for the social network that I apply the game, and then I will interpret the game with the name of people into the graph here. Okay, so let's see some examples questions. Okay, so this is the place and then the vertex pair here. So table 1 and table 2 shows the names and the distance of 6 places in Perak. So diagram 1 shows an incomplete undirected graph here. So you have to complete the diagram 1 by drawing an undirected wave graph. Okay, so we will complete the graph here. Okay, so we will do the graph together. Okay, ks to m, so I can connect it ks to m. So undirected, so here will be 8 here. K to m, so k to m I can link together. K to m will be 8.4. K to t 5.2. S to t 5.9. Okay, 5.9. S to m will be 3.5. 3.5. S to ks 11. Cj to s is 4.9. Okay, 4.9. Cj to ks, so I have to draw like this. Oops. Cj to ks is 15. Cj to t, so Cj to t okay, so it will be 10. So this is the line here. So in your notes, please use your ruler to draw the line. Okay, so this is the question number 1a. 1b, so draw a tree with a minimum total weight which every place being visited once only. So you have to draw a tree. So remember what is the tree. So the tree is a subgraph in which that all the vertices, they are connected by one edges only. Okay, so this is the definition, so you have to remember. Alright, so how do we do the how to say the lines here? So we will find the graph, the tree here. So I wish I can do the minimum total weight here. So I have to calculate the minimum size here. Okay, so we still have every single point. So I draw out the vertices. Here is ks, here is m, here is s, cj, we have another one k, we have t. So this is the graph, but I would like to choose the minimum total weight here. So the graph will be like this. So we have ks to m, So we have M to S, S to CJ, CJ to T, and then so this is the line. So we have 8, 3.5, we have 4.9, we have 10, we have 5.2. So you can calculate the minimum distance from C. So from here you can see I would like to eliminate some of the big number, which is 11 and 15. So confirm I will be eliminated here. Why? Because if you have a big number here, so you will face this is not the minimum weight here. Okay, so I would like to choose the numbers which is smaller with the smaller weight. Okay, so this is the way you to this is some tips lah for you to draw a tree with the minimum weight here. Okay, so calculate the minimum distance. But in C, we have 8 plus 3.5 plus 4.9 plus 4.9 plus 10 plus 5.2. So you get the answers of 31.6 kilometers. Okay, so this is the answers for number 1. So let's see the question number 2. The table shows the 4 types of fruit for several people. So we have this. So based on the table, so you have to draw a graph with multiple edges. So confirm here you have the multiple edges here. So in food as the vertices here, so we will draw A. We have draw 4, so I have to draw 4 vertices here. Alright, so we have chicken rice, so I do a short form of CR. Fried noodle, I will FN. Nasi lemak, we have NL. And fried rice is FR. Okay, so in chicken rice, we have Mervyn, Raj, Helen, Wong, and I here. So we have, but you can see, well, I have to find the same characteristic here. So you can see Mervyn love chicken rice and nasi lemak. Okay, so I will connect chicken rice to nasi lemak. So here is Mervyn, and then we have Raj. Raj here is chicken rice and fried noodles. Chicken rice and fried noodles here like this. So there is Raj. So Helen loves chicken rice and fried rice. Chicken rice and fried rice. So I will connect it. This will be Helen. Next, we have Wong. Wong loves chicken rice and fried noodles. Chicken rice, fried noodles. Connect this. So here is Wong. Next, I loves chicken rice and nasi lemak. Okay, chicken rice and nasi lemak here. So here is I. Okay, so we will settle the first. So Marie already done. Nurul, nasi lemak and fried rice. So nasi lemak and fried rice. So here is Nurul. Next, Atika loves nasi lemak and fried noodles. Also, nasi lemak and fried noodles. So it will be here. Here is Atika. Okay. Next is I already done. Puspa, here is nasi lemak and fried rice like this. Here is Puspa. Okay, so Farouk, we have Helen, we have Julia, fried rice and fried noodles. Here will be Julia. Next one is Nuruddin, Farouk. Okay, Farouk with the same. Okay, so here will be Farouk. Okay, so I think we have done with the graph here. This is the sum. This is the graph lah. Okay. Next, between the types of food and names of people. So which group you use to represent the vertices? So in this term, so I will choose food as vertices. Why? Because why? The reason is each of food favored by two people. So okay, I will justify this. So if you choose your names as the vertices, so you cannot connect all the vertices here because your vertices is too many here, and then your edges is very less. So if the food as vertices, so it can connect with another food, which is we have, and then the edges here will be the students. Okay, so I will choose food as vertices lah in this case. C. What is the relationship between the sum of degree of your graph with the total number of food choices? So I will use, so we know sum of degree here is 2e. So in this case, what is the sum of degree? Equals to total number of food is multiplied by number of people. In this case lah. So D here is between the table form and graph form, so which is clearer in showing the relationship. So I would like to choose the undirected graph. Why? Because this is a network. This is a network, so shows the relationship. What is the relationship? Not the boyfriend-girlfriend relationship. So between the, you can say in this case between the food and the peoples, and between the food and the peoples lah, like this. Okay, so in the textbook here it says the organization chart is a network because it shows the relationship between the individuals involved based on the chart's requirement. But if you don't know, never mind. So you can, if you want to write, you can write like this. I think it should be okay because this is a like an opinion question, like your KPKK questions. Okay, so before we end, we will see another questions. Okay, so this is regarding the transportation problem, which is a kind of problem solving here. So we have this is Mr. Maswi works in Kulai, so plans to visit his family in Miri on a certain weekend. Okay, so on Friday, Mr. Maswi work ends in 12:30 noon. The table below shows the choices of domestic flight routes of a private airline in Malaysia on Friday and Saturday for that week. So this is the table. So determine the most economical flight from Johor Bahru to Miri. Alright, so in order you to see whether it is economical flight, so it must be a very cheap. It is very cheap here. So from Johor Bahru to Miri, so Friday we have no flight here. So the only way I can do is so I want to choose the most cheaper price. So you can see Johor Bahru straight away go to Miri, we have 259.3, and then next from Johor Bahru to Kuching, and then we have the we call it as what, how do you say, the not transfer, what the word means, we have to transfer, I think. So like, or we call it extract. Okay, so we can see, in order to you to choose the economical flight here, so you must choose the cheap price lah. So you can see we have the straight flight, direct flight, we have this price, and then we have another one which is transit, or we can transfer. So we can see Johor Bahru to Kuching, so this is the flight lah. So we choose which flight here. This is the one color, so I choose another color for the prices. So I can choose like this. This is the flight. Okay, so another flight I can choose like this. This is also another flight. Okay, another one. In this another one I can choose this, and then straight away I can from this. This is for Friday, and then next one is Saturday. So Saturday I can choose the flight. Okay, this is the price, and then Kuching to Miri, so I can choose like here. Okay, and then next one is I can choose, oh, so I cannot choose any, so I can choose this. Okay, so I can also choose this. Okay, so you can calculate one by one here. So we have, okay, so I compare all the prices, so you can do the comparison here. So one is RN 259.3. So another pen, so I will another color prices how much here. So you can take your calculator to calculate here. So you have 293.3. Okay, so we have another color here. We have 124.3 plus 149. So we have 273. Okay, another one which is I use an orange color. We have 258.3. Another one which is a light green color, so we have 238.3. So you compare these prices, so I will choose this price lah, because this is more economical, so it's more cheaper. So what is these colors? So I can say the answers here is Johor Bahru to Kuching, which is Saturday 6:05 hours, and then from Kuching to Miri, so also Saturday, which is 11:45 hours. So this is the answers. So this is the way to find the most cheaper flight lah. And then B, so determine the best flight that Mr. Maswi can choose if he needs to go back to Peninsular Malaysia on Sunday. So in Sunday, so I can choose Sunday. Okay, so I don't know whether, so I back to the how to say, back to the Sunday, so I can choose the best flight lah. So maybe in your opinion, so if you want to choose a best flight for you, so you must can have a time, you can arrange yourself which you think you should be the best lah in order to how to say to accompany your family or whatsoever here. So or you can or you can, this is a personal opinion lah for the family part. Okay, so what is the best flight? So here I will choose I think I will choose the night time here. Okay, so I will choose this 273. What is this? So it will be JB to Miri, JB to Kuching, sorry, JB to Kuching, which is 19:30 hours Friday. So we have Kuching to Miri, also Friday, 21:55 hours. Why? So you can see Mr. Mazvi can accompany with family with longer time. So okay lah, so just like so in order to have a best flights like this, like conditions also when you go to university, so you already settled, so you want to go home, so you must so you have to choose the best route lah. So maybe best time to go back to your hometown, so I would rather choose the latest one. I will choose the latest time in order I can go back to home faster. So this will be the best time lah. Okay, so I think after this question, so here comes the end of chapter 5. So thank you so much for listening, and then I will see you in another time. Thank you.